Hi and welcome back. In this video we're going to look at something substantially more complicated. So please stay with me and let's look at queuing in threads with shared state. The first thing I'm going to do is import a few things. So I'm going to import time and random, as we know, to do our fizzying. And I'm also going to import queue. The queue module has a queue in it which is going to be essential for our program to work. And I'm going to explain exactly what this queue does and why it's different from a deck. And then, of course, from threading, we're going to import thread to start with. We'll then use a thread pool executor later. We're going to have our global counter. And we're also going to have two queues. We're going to have a job queue. And we're going to have a counter queue. Okay. Job queue is going to be the command, the things to be printed out. The counter queue is amounts by which to increase counter. Okay. All right. Now, we are going to be doing something, which is every time we want to increase counter, we're going to put 1 into the queue. So we're going to put the number 1 into this queue. Then we're going to have some code looking through this queue, and whenever a number appears, it's going to increase counter by that amount. At the same time, we're going to have another thread going through this job queue, and whenever it sees something appear in there, it's going to print it out. That's essentially how this program is going to work. So, let's do it. We're going to first define our increment manager, which is going to take in our global counter. Remember, multiple threads could be doing this at the same time. And then we're going to do while true. It's going to get the counter from this counter queue. Remember, this counter queue here has a queue of multiple numbers potentially by which we want to increase the counter. So increment is going to be counter queue dot get. Okay. And this is important because this waits until an item is available and then locks the queue. Okay. So this is going to wait until an item is available, and when it is, it's not going to allow any other threads to get anything until we are done. Then we're going to say old counter is counter. Counter is now old counter plus the increment. Then we are going to put something into the job queue. The new counter value is counter. And we're also going to put in our lines. Okay, we're going to put these two things. And finally, counter queue dot task done. This unlocks the queue. So now another thread could go back and get something if they wanted. So as soon as something comes in here, this counter queue is now locked. The thread has that resource. No other thread can access this resource until we call task done, and that marks the queue as not locked anymore. Another thread can then go through this get. Okay. Cool. We're going to run this. Target is going to be the increment manager. And daemon is going to be true. And what this means is this thread is going to run continuously forever until until it finds an error, essentially. And then we're going to start that. Okay. So this thread is going to run forever, always, while true, always checking this counter queue, trying to get a thing. It's going to wait until an item is available, and it's going to lock it, and then it's going to go through it, and then it's going to call task done. Then it's going to repeat. Again, it's going to wait for something to become available, and so forth. Now, if we want to print, we're going to create a printer manager. Just going to scroll down here. Again, this is going to be while true. it's going to get the lines in the job queue for line in job queue.get. And again, this locks the queue and waits for an item to be available. It's going to print the line out. And at the end, it's going to be job queue.task done. Okay. Once again, we are going to run this as a daemon thread. And we're going to start that. Okay, so the printer manager and the increment manager are going to run continuously because of that daemon flag. The final part of our program is to deal with increasing the counter itself. So this is going to be running constantly, getting values out of counter queue and increasing the counter by them. This is going to be running continuously, printing things out. All we have to do is to put something into our queue. So let's create another thread or another function that is going to be our increment counter. And this is all it's going to do is do counter queue.put 1. It's going to put the number 1 into the queue. Then it's going to get received by this increment manager, which is going to increment the counter by that amount. And it's going to put 2 things into the job queue, which is then going to print them out as it runs. Okay. Then we're going to make a few worker threads. Worker threads, these are going to be threads where the target is this increment counter. For thread in range 10, we're going to make 10 of them. And then all we're going to do is start them. So for thread in worker threads, thread start. And we're going to wait for them to finish for thread in worker threads, thread.join. And at the end, we're going to wait for the counter queue to finish, to not have anything left in the queue, and the job queue to also not have anything left in it. Notice how we are joining the queues, not the daemon threads, because the daemon threads are never going to stop. They're always going to be running, okay? So we're joining on the queue. When they become empty, we will essentially be done. As you can see, this is substantially more complicated. Now that you have shared state, you have to start having queues in there so that your threads cannot interrupt one another. Let's run this code and see what happens. Oh, I forgot a pair of brackets. What you put in the queue has to be a tuple. My bad. Let's run this again. And there you have it. Now you get your code that looks sequential. Okay. Again, you could just not use threads and it would achieve the same purpose. But if you wanted to use threads, you'd have to use these queues. And indeed, if you add the random weights, which we will do, you'll see that this still works. So we're going to add these weights everywhere. Like there, we're going to add some here. We're going to add some here. We're going to add some here. And then we're going to run it again. And you can see that now we are waiting for our code to sort of go through this queue, but only one thread is able to go through this increment at once. So these still happen one by one. So not terribly simple, let me tell you that. Not terribly simple. Again, you could use a thread pool executor to improve this code down here if you want. We're not going to get into that, but the code in the GitHub does have this in there. So again, just to recap, what happens is we say we're going to access this global counter variable. It's essentially just to tell Python that we don't want to create a new variable called counter. We want to use the global counter. In here, by the time we access the counter's value, this has already prevented 2 threads from doing that at the same time. So get waits until the item is available and then locks so that only one thread can execute this at a time and get a value out. If you have 10 threads calling this, only one is going to be able to use that resource. The other 9 are going to wait until task done is called and this becomes available again. So you've got a single thread getting the increment, which is 1. Then you access the current counter's value, which will be 0. Then you'll increase it by the increment, which is 1, make it 1, and put these 2 things here into the job queue. Then task done. So you go back to the top and another thread is able to do the get. When they access the counter value, that's 1 now because the previous thread already incremented it. And then you can increase it again and so forth. So essentially what you're doing here is you are creating this bottleneck for threads to only be able to access the resource one at a time. Okay? Again, this is essentially single-threaded code, but it goes to show that when you need threads to share state, you need these queues. Think of the printer in your office, if you have one. The printer in your office can receive jobs from a lot of different people at once, but it can only print one at a time. So that's what we've got here. We've got a queue of print jobs, and the printer is then just continuously printing them out as soon as it sees them, but it doesn't do that all at the same time. It does them one by one. Similarly, because we're accessing a unique resource, the counter, we also must do that one by one. If we get 2 things incremented the counter at once, we saw what happens in the last video, they just sort of go mental and they start changing it all at the same time. If you got your printer to print 2 things at once, you can imagine how that wouldn't go so well either. You'd see sort of words from one document and words from another all printed together. It wouldn't be pretty. When you want a shared resource, you must use a queue. And the queue.q package here, the queue package, is good because it has this locking thing and this task done thing. So this is made for multi-threaded access to a queue. The deck, which is something that is atomic, does not get interrupted when you add or remove elements from it, but it also does not lock. So you can have multiple things appending things to a deck at the same time. And that can be handy in other situations, as you'll see from the talks that are linked to you later on. That's it for this video. Hopefully this didn't melt your brains, and I'll see you on the next one.